All right, so I did an accidental mistake of somehow not starting the recording, even though it said it was recording. I got to this point. I'm just going to start over. All right, so to start off, we wanted to open up a fluid flow fluence. That's what we have here. We go to geometry. We do well, it would have been uh, to I'll just start it over. What's one more attempts? Delete. Okay, cool. Okay, so fluid flow fluent. We're gonna drag it in here for our geometry. We're gonna right click. We're gonna do new designer uh, geometry. Wait for that to start up. All right, now we're in, we are gonna start designing our geometry. So we go to modeling, or yeah, with our z-axis. And we're just going to start out. First of all, we'll convert our units to inches. Now we're just to start sketching a basic outline of our wind tunnel. All right. Now that we got that done, we can go to dimensions and start dimensioning. So that should be 3 degrees. Our H1 is going to be, hold on, I have to open up the notes because I forget off the top of my head. I believe it is 15 inches long. Our H2 is going to be 24 inches long. Our H3 is going to be 12 inches long, and H4 should be 42 inches long. Vertical should be half of 22, which is 11 inches, because we're going to do some stuff to make it all fit. Over my camera here. That being 11, this should be 3 because it's supposed to be 6 inches. And that looks all nice and good. Oh, I did not know I could do that. Oh, that is so nice. All right, now we got that done. We can draw, go here again. Oh, wait, no, sorry. Go to modify. So first of all, we are going to do our box select, highlight all this. We're going to replicate, set that to 180 degrees, and then we are going to select that. All right, with that selected, you need to flip vertically and then plop it right back down. Now we got that there. You go back to draw, we can connect these segments up to each other, close our surface. Now we can go back to our box select this whole thing, go to our concepts, surface this thing we can apply, go to our surface, generate, and we have our surface here. So now, I think that should be good. Good, yep, we got our great check mark. Okay, now for the mesh. So what we're gonna do is we're going to go in here, we're gonna hit edit. Wait for that to load. Okay, now that our geometry is loaded in here, we can start working with it. So first thing is first, we're going to go to select sorry, hold on, I have to move the little tabs here. I have a bunch of Zoom meeting stuff in my way. We are going to do select line. We're going to right click. We are going to create a name section. This will be our inlet. Okay. We are going to do the same thing for our outlet. And then we are going to control click these, create name section, top wall, and do the same for the bottom. All right, we should have these name sections in here. Perfect. Now we can click on mesh. So we're going to do a sizing mesh. Going to select here. Let me double check. So we select this. Now we go to geometry, we apply. For this, we're going to go to number of divisions. Number of divisions, we do 1500. Let's do 1800 this time. Let's see how that works. Then we are going to go to, no, let's keep with 1500. All right. Uh, capture curvature, we're going to turn this to no. And then for our behavior, we're going to turn this to hard. All right. And now we're going to hit generate. And this will take a bit. I'll really quick just. All right, we get this little warning, but should be fine. So now we should have our mesh. All right, I'm ready to keep going. So now we're going to do a sizing. Select here. Uh, sizing. We're gonna, yes, geometry, element size, number of divisions, 1500. Capture curvature, no. Turn this to hard, and we will hit generate. All right, we should have now another mesh, or more fully complete mesh. So now we are going to do another sizing mesh, but what we're going to do this time is we're select surface, go to sizing and face. We're going to keep element size. We're going to put this to 0.01. Same thing, no to the curvature, and hard. Now when we generate this, all right, that took a while, but we got it. All right, so now when we go to our mesh, we should have a decently good mesh. All right, that looks good. So we're going to go files. We are going to go, actually, uh, do I have to close the mesh? Oh, I'm going to update. There we go. Okay, that's all good. Now we can finally move on to our setup. Oh, by the way, my name's Liam Larenas. I forgot I did multiple takes of this, and I think I just forgot to put in the front of this one. Um, but from here on out, these are just going to be all three of them using the same geometry and mesh. So here we go. So we're going to sit with our default settings. Default settings. Wow, that's I'm a bit tired. That never mind. Uh, I hope none of you actually, and I hope what Ozbay said was true, and that none of you guys go through this, not because of like, oh, I didn't do whatever. I'm doing the work because honestly, this is the most I've understood ANSYS in a while. Uh, but mostly because I feel like this commentary is like awful. All right. This might take a while to set up. I remember it did the first time I did this. But no, actually it came out pretty good. All right. So let me see if I remember what to do first. Um, so for our model, we're gonna do this. We're gonna do set it to laminar. Hit OK. All right. And we're just gonna check, make sure our fluid is air. Nice. Okay, we're gonna close that. So now we're going to set up our boundary conditions. So we're going to set our inlet speed. Ooh. So the first one I'm going to do is going to be 20 hertz. So the based off of this right here, I got that 20 hertz is around 4.6062 meters per second based on the formula we were given right here for the test section. Then to find the inlet velocity, we can multiply that by the ratio of the inlet to the test section, which gives us 1.25624 meters per second. It should go in here. And we hit apply. All right, and now we close. All right. So real quick, I do want to check. Um, all right, it took me a while to figure out how to open it again. Just nine-ness, whatever. All right, here's all of our boundary conditions. They all look to be in place. So now we should be able. Okay, I remember now. Okay, hybrid initialization. So for initialization, yes, make your annoying noises. Okay, initialize. There we go. So this thing, run calculation. So number of iterations, we're going to do do 300. 300. Okay, and everything looks good. Calculate. And we should see it converge. Oh, oh, oh. All right, I think that's good. All right, it came out a little different than the first time I did this, but I think it works out. So now we're going to go and start making our contours. So if we go results, where is it? Where is it? No, no, no. Graphs. There we go. Contours. So first we're going to do our static pressure. So we're going to do our interior body surface. Pressure, static pressure. Compute and save, and oh, let's save this as 20 it's static. All right, compute, save, and display. That's what we get. All right, we'll close that. Now we will create one for our dynamic pressure. Dynamic, dynamic, 20 hertz. Compute. Oh, we got interior body. Compute. Save and display. Looks all right. We're going to close that. Both of them down here. Now we are going to do pressure total this time. Total. 20 hertz. We're going to compute it. Save and display. With that, I'll do one more. This one is going to be velocity. Do velocity. We're going to do velocity magnitude. Compute. Save and display. And we're going to close it. And that looks about right, I'd say. So now we're going to generate our plots. So we're going to do a XY plot. So for these, to export them to Excel, we're going to plot them in Excel. You just do write to file. You save it as a text file or an XY file, I think it's called. You scan it from your notes, put it into Excel, and then you just create the diagram from the raw data. So first of all, we are going to want the center line. So we're going to do new surface. We're going to do line and rake, line tool. So we're going to call this new surface center. So it's going to start at 0. It's going to go to, let's see, calculate this out real quick. I believe it's 2 point something. Let's see, 15 plus 4 plus 12 plus 42. It's 93 inches, which 93 inches to meters is 2.3622 or 265, right? We're going to create. We'll do 622. No, 625. That should be good. All right, now that we have our center, we can take that and use that for our pressure. So this is going to be static pressure. We could just do static 20 hertz. Save and plot. Close it. Uh, okay, let me try this again. Center static 20 hertz. Yep. Save and plot. Hmm. Um, Object with same name already. Oh, static. We'll do XY. All right. There we go. That looks good, I'd say. Yeah, looks about right. All right. Next, we'll create another one. This will be dynamic XY 20 hertz. So we'll do pressure. We'll do dynamic pressure, center, save and plot, and then close. I would say that also looks about right. We'll do pressure. We'll do total. We'll do total XY 20 hertz to our center line, save and plot. This one is going to look a little weird because of issues with meshing. Um, along the center line, the mesh isn't coarse enough, so you get these very jagged ups and downs where the readings of the mesh are just kind of all over the place. Um, I Yeah, all right. And then finally, we're going to do our velocity. Do velocity magnitude, leave velocity x, y, 20 hertz. We're going to do center, save it plot, and we're going to close. And there we go. All right, now we just need to do it for the other two cases. So what we're going to do is we're going to go back to our inlet. Oh, I hope this works. Actually, let me pause this real quick and get everything else saved. Um, and then I will change it. All right, everything's saved. Everything should be good. Now I'm going to go to my boundary conditions. We're going to go inlet velocity, and we're going to change it. So we're going to change it to the next one, which should be 2.6139387 meters per second. So we're going to apply this. All right, now we're going to close it. Now we are going to go down to initialization and initialize. That should be good. I have everything saved. Okay, we are initializing. All right, initialization is done. Now we're going to run our calculations, which should be here we go. Run calculation. We're going to do 300. Everything should be good, and we're going to calculate. Here we go. Should flat should what's it called at round 100. Correct. Oh, all right. Yeah, around 100. Perfect. All right, now I actually want to know, is this any different than before? Do I have to replot all of these? Because if not, that would actually be amazing. Let's see. Save and plot. Is this different? Um, I should have checked beforehand. I believe it is though. I really should have. Okay, you know what I can do? I can go to my files. I can go to desktop, ANSYS. We're gonna go to not the 40, it's 20. 20 hertz. We're gonna go to which would it be? It's XY. Which one is this? This is velocity magnitude. Okay, velocity. So velocity XY. We're gonna open this with Notepad just once. We're gonna check. So 2 point, so I can, yes, okay. So at the very start at 0, it should be 1.256 um 24. Oh, that makes sense. Yes, because hmm. So it is. Oh, it's not the same. Oh yeah, that's what I want. It's not the same. Okay, perfect. So yes, this is the new one. All right, so I should be able to check uh what? There we go. Yes, yes, yes. This technically should just be completely straight. You can see where the mesh is a lot better. It is, but as it goes through, it bounces around and stuff. It's yeah, mess. But let's check our dynamic about 4.43. So if we go here, we go dynamic, XY, this up. That is different. All right, perfect. So these are all our new graphs. So it automatically adjusts it itself. I'm just going to export all of these as their own. But I believe our contours, actually, I don't know if our contour ones will look the same. Where is contour? How have I lost it? It's graphs. Compute, save, display. Okay, so we just have to compute and display them again. So we just go in, compute, display, close, compute, display, close, compute, display, close. All right, that should do it. All right, so these are all the new values. So what I'm going to do is now save these all to put in my document, and then I will convert all the data. I will save all the, there we go, these as 40 hertz, and these will go into my Excel sheet over here uh, with the other data. And then all that's now left to do is the 60 hertz. So I'll be right back. All right, I got everything transferred over. That was really annoying. Okay, so now that we have that done, I can go back up to our boundary conditions and go back to the inlet. So now we're going to be doing 60 hertz, which, oh, uh, 60 hertz gets us this velocity attached section, which we do our basic ratio, which gets us, let me actually calculate that out one more. I don't like that number real quick. Hold on. Just notice it's one digit shorter and it's bugging me. 0.2489 times 60 minus 0.3718. All right, and then multiply that by 6 and divide that by 22. And that should give us 3.97151. All right, well, we're going with it. So that's going to be our meters per second. So we're going to go back to our flow here, paste that in, and we're going to apply it. So now that's applied. We're going to close our thing. We're going to go back to our initialization. Click on that. We're going to initialize. Yep, got it. It's doing this thing. Now we're going to run our calculation again. 300 iterations. I hope it converges even faster this time. So the second one took a lot. First one took a lot of time, and the second one didn't. And this one, if we calculate it, come on. Oh, I should be watching the scale residuals. Oh wow, was I right? Was my vague guess of whether it was going to be quicker? Yes, and just by a bit. Yeah. All right, calculation is done. Here's our new contours. I just realized this says 20 hertz and it's gonna say it in the photo. I will just leave in the documentation to ignore the little 20 hertz. I could have fixed it so easily too. Well, I really don't want to save all of them again. I will just put a little disclaimer that this is not, they're not all 20 hertz, that the 40 ones are 40 and the 60 ones are 60. All right, but now looking at it, we're gonna compute, save and display, close. Wow, look at our beautiful velocity. It gets slow, and then as it goes, it gets faster, and then it gets really fast, and it slows down a bit as it gets towards the diffuser. Oh, cool! You can see the what's it call it? Uh, really see the this like what's it called? Slowing down, just the air near the boundary. Because the shear fluid shear. Oh my God, I really need to learn my terminology better. But yeah, no, I'd say that looks good. All right. And now we just need to check our other ones. So here is total. This one should come out like, yep, total pressure. Shouldn't really change too much because, unless you have like that, what's it called? Shouldn't change unless you have, I believe, turbulence is what causes it to, kind of turbulent air causes it to, what's it called? Energy, whatever. Yeah. All right. Dynamic. Cute display. Dynamic pressure. Yep, as it gets here, gets higher because it's speeding up. As it goes out, it slows down again. Basically, inversely, you know, proportion. It is directly proportional to our velocity. So higher velocity, higher dynamic pressure. Cool, awesome, great. So now we can move over to our static pressure. Say display, close. Looks good. Exact opposite as it speeds up with less static pressure because of the what's it called as it speeds up just at the pressure drop. Yeah, and you see as it slows down. Yeah. All right. Cool. 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 And then our new plots. Say plot looks good. Velocity at 4.0 3.94, which I believe we go back 3.9. Yep, that's it. That's good. Awesome. I love ANSYS for this. Actually, this is the first time I will say I'm actually congratulating ANSYS. I feel like it would have done something weird where the old graph stays, but automatically updating them. It's actually really cool. So that's cool. We can do our total, which is also still messed up. Love to figure out if there's any way to fix that besides just making a giant mesh, but I'm assuming I'm assuming there is. Then why would they have that if it, you know, is always messed up? Um, oh, I guess it's not always. Yeah. Anyways, dynamic. Yeah, yeah, looks about right. Our static should be basically the inverse of that. Yep. Beautiful. Okay, that is all of the plots and everything. I will now export this to Excel. Well, not this one. Well, yes, these ones to Excel. And then also put them in the docs and I'll label everything. It'll be great. Um, I don't know why we couldn't just do an image of these. Not my reason to ask, but I mean, not my whatever, you know it. Anyways, yeah, that's it. This has been Liam Larenas.